We are solving limits analytically. We have the limit of 3 roots of x minus 10 over 3 roots of x minus 11 as x approaches 2, and I'm claiming that this limit is equal to 2 over 3 raised to the 2/3. So what I'm going to do first is get this out of radical form, get it into exponential form, and by the properties of exponents we can take this and rewrite it. As you can see, I've got x minus 10 over x minus 11, and that whole thing is in parentheses raised to the 1/3 power. Now you can take these parentheses and actually bring them outside, rewriting the limit inside of those parentheses, and it's all raised to the 1/3 power. Now this happens to follow a theorem that I'm going to be stating here in just a moment. But let's look at what I do here. So once we've rewritten this now, we do the direct substitution, plugging 2 directly in for x, and we got 2 minus 10 over 2 minus 11 reduces down to negative 8 over negative 9. Now of course the negatives will cancel out, and we will be left with 8 over 9. And by the properties of exponents we can split this up. 8 raised to the 1/3 power is 2, and rewriting 9 as 3 squared, by the properties of exponents we would multiply these together, and 2 times 1/3 is 2/3. I'd like to go back to a theorem regarding this particular problem. But before I do that, remember what we have here. We have 3, which happens to be an odd number, and 2 is a positive number. So let's keep that in mind. Now let's head towards the theorem. So this theorem about limits. If a function has a limit as x approaches a, then, now this should look familiar, this is what we pretty much have, and you can see here that I'm bringing this radical outside, rewriting the limit underneath it. So these two limits are equal, provided either n is an odd positive integer. Now remember what n was in our problem, it was 3. So that would fall under an odd positive integer. However, if n were an even positive integer, if this were an even number, positive integer, and the limit of f of x as x approaches 0, the limit of f of x as x approaches a is greater than 0, then this would also be true because of the OR. But in our particular case, we have n is an odd positive integer. And so this is what we did to solve the limit.